So today, automating solver, download the portfolio optimizer and get it open. While you're opening that, I will talk you through what this thing is going to do for us. I've got it open already. Show in folder, and we can go ahead and save this while I'm at it. It's in an XLS. It's in an XLS format, which means I have been doing this example since before 2007. It's a great example. I used to use it quite more extensively in the class. It was a running example I did for several days, but now it's just for today. Portfolio Optimizer Winter 17. Okay. So here's the idea. Here's the background. Let's suppose that you decide. Let's say that you just accepted a job and you got $10,000 signing bonus. By the way, what kind of signing bonuses do they give you these days?
25.
25,000? Oh, that's more than my first salary. You get $25,000 signing bonus. And you decide, I'm going to invest it. So you've got this money that you're going to invest. Now, you have chosen a set of stocks. You've done your research and you think, okay, these are the stocks that I want to invest in. There's 10 of them. There's 12 of them. I don't care how many there is. There's 5 of them. Now, you're going to say, you know what, I'd like to, things are going pretty well in the market lately, and I'd like to allocate this portfolio so I get at least the 1%, let's say at least a 1.5% monthly increase. I want my portfolio to grow 1.5% a month. Now, subject to that constraint, you'd like to reduce your risk and make the risk as small as possible. That's what this model is going to do for us. We tell it the stocks. And then we say, give us a return, an expected return. I'm shooting for this return. Now allocate the stocks in this portfolio so that it minimizes the risk. That's the chore that we're after. And so if we look at this, so here's data from, oh wow, late 90s. I would not run the model on late 90s data and use that to determine how to invest today. Especially since we can't use Dell. What's wrong with Dell? Yeah, they're now private, so we'll have a hard time finding public information for them. So let's go X. I'm going to change them for ExxonMobil. I would like to have 10 stocks in here. By the way, the Add Tickers button should just bring up a form. This is the form I used to teach user forms with in this class a long time ago. So it doesn't do anything all that interesting, but that's what that is. Now, is there any of you that when you click on the Add Tickers button, you get an error instead of getting the form? Okay, if you have that error, then if you look at the error, it's probably on something that's absurd, like the write function, or the uCase function, or something. So, yeah, this is what happens when you don't have a required add-in. You don't have a required library. Let's take a look. So if you're getting that error, let me go ahead and open up the code, and I'm going to. You might have to hit stop, but then choose Tools, References. And what you'll see is that solver is checked, but there's some kind of question mark. It says it's missing or something. Is that what yours says for solver? Yeah, it's trying to refer to solver through the code, and it's going, ain't no solver here. So what that means is that you don't have the solver add-in installed. So let's just go ahead and add the solver add-in. So back to Excel, I'm going to choose File, Options. File, Options. Over here on the left, I'm going to choose Add-ins. And then from the Add-ins panel, I'm going to, down here at the very bottom, Manage Excel Add-ins is the default there, and I'll say Go. And I'm just going to check on the solver add-in. Presumably you have solver because it ships with Excel. It's an add-in. It's not written by Microsoft. It's written by a company called Frontline Systems. That's what Frontline Systems does. They make optimizers. My guess is they give this optimizer to Microsoft just so they'll add it in. I don't know if Microsoft pays them anything for it or not. Maybe they do, maybe they don't. But if you get to where you need optimization that's beyond what this solver add-in can do, you can go to Frontline Systems and you can buy, it's thousands of dollars to buy a more capable solver. They figure, if you're doing something that this thing can't do already, you're doing something that's going to save you a lot of money. You can afford to kick a little bit to Frontline Systems. And it'll cost you $2,000 or $3,000. So once you got that checked in, say OK. You'll probably have to close Excel, open Excel again, Open this workbook again, then you should be good to go. All right, so while they're getting that reopened, let me just kind of talk through what this code does. So this code is going to take whatever list of ticker symbols we have here. It's going to go to finance.yahoo.com and pull in the historical data for those. It turns out that the code that we use for that, I'm not using Internet Explorer for this. There's another object that's part of the Windows operating system called the XML HTTP object that allows us to make a request directly to a web server and bring that data back. I didn't teach that to you in this class because it won't let you log into a password-protected website. It suffers from the same problems that the web query wizard suffers from, in that you can't just, it has to be a website that you can just go to. But it's a little bit faster, in fact it's quite a bit faster than Internet Explorer, and it will let you download files, which Internet Explorer won't let you do. So it's there, and if you find yourself thinking, I'd like to do that, there's some code in this workbook that might get you going in the right direction. So it pulls in the historical information for that, for the set of stock tickers that we have here. It then calculates the monthly percentage change. So does this go, by what percent did this go up over the last month? Or what percent did it go down over the last month? And it uses those monthly increments to get a feeling for the volatility of the stock, as well as to tell, is this stock, how well is this stock improving? How is this stock increasing? It then builds a model that we can optimize. So I'm just going to go ahead and hit Process Model on this, and we'll see some tabs. It will create a bunch of tabs, bring in data. We'll see those all get created down here. You can see that it pushed the plus sign over, but hasn't updated the screen to show the tabs that it's created. So there we go. So pretty quickly, it brought in this historical data. I'm just going to come over here and look at the Yahoo tab, which is where it's pulled that information in. So this is for the last, it used this page to bring it in over and over again. So the last one remains here is the ExxonMobil data. And you can see that it's, oh, you know what? I'm not sure I want to use, well, I'm using this data from the late 90s. I guess it's fine data to use. I was going to update that. Well, I'll just use this data, that's fine. And it's just showing here's the percentage change. So from August to September 1999, it went down by 0.7%. It looks like it had a lot of down days here in the late 90s. So it sounds like oil and energy stocks weren't doing so well in the late 90s compared to the way they've been doing lately. Okay, so from that's where we bring in the raw data, and you'll notice that the raw data that comes in is only A through H. The sub-procedure calculates this percentage change just by looking at how it changed from the prior month. We then bring that information onto a Consolidate tab, and it's just the percentage change information. So I've got these percentage change numbers for now all the stocks consolidated here onto one page. Questions? It then builds the summary sheet. The summary sheet just looks at those same tickers, and it looks across this vector of data here, and it says, what's the average, what's the standard deviation? And it brings those onto the summary sheet. So for each ticker, I have an average and a standard deviation, and we can see how things go here. Everyone's positive. Well, the late 90s are kind of like, it's kind of like the world is right now. Everything's going up. Let's see, from the late 90s, we had 8 years, and then we had a crash. And now it's been 8 years since the last crash. The market looks about like it did in the late 90s and in 2007. I'm feeling a little bit nervous, but we'll see. And then we have a correlation matrix. So if I look at this, what are our most highly correlated stocks? This is what, in fact, this is exactly what conditional formatting was invented for. The most highly correlated, well, they're not all that highly correlated. 0.5, do you see one higher than 0.5? 0.546, I think that's it. So Ford, interestingly, Ford and American Express are our most highly correlated stocks. What does it mean for a stock to be highly correlated? Two stocks to be highly correlated?
A change in one is most likely, a change in the other is most likely to happen. A change in one.
That's right. If I say, well, Ford was up a little bit today, I would guess, well, my guess is that American Express is up a little bit today. They tend to move in the same direction. In fact, if it's a correlation of 1, which is what we see on the axis, every time American Express goes up, American Express goes up. Every time American Express goes down, American Express goes down. So the diagonal is not that informative. but anything off the diagonal is. Now, we've got some low ones here, Apple and American Express. This is a negative correlation, 0.1. It's not really strongly negative, but it's negative. What does it mean? When American Express goes up, Apple tends to go down. So as long as these guys are both performing well, oh, and it looks like they're doing pretty well. They're getting 2% average, 2% monthly increase. That's a really good pair to have, right? They're both doing well, and they offset each other. So when one goes up, the other one goes down. I predict that we're going to find these guys end up I say I predict like I've never done this before, but the truth is I don't remember how it happened. But my guess is these are going to come in. These are going to be ones that are favored here by our algorithm. So now the idea is we'll come to the model tab. Now the model here says, all right, we now have a covariance matrix, which I guess is kind of like the correlation matrix. We have a finance major here that can probably tell us the difference. But we use the covariance matrix to get the overall standard deviation of the portfolio, which will give us a measure of the risk. The higher the standard deviation is for the portfolio, the more risky this bundle is. If I could reduce that standard deviation, that would be a good thing. So here we have then the same set of stock tickers. Right now they're allocated equally. We haven't done any optimization yet. We've just said we've got 10 stickers, give a tenth of our portfolio to each one of these tickers. And then we calculate what's the expected return. So if we look here, we have a minimum return and a maximum return. No matter what I choose here, I should not be able to get less than 2% average monthly return. Well, that's great. But I shouldn't expect to get more than 5 or more than 4.8%. Who's my 4.8%? Who's that? Microsoft. So Microsoft's doing pretty well in the late 90s. So that's kind of the boundaries that I can expect to get out of this portfolio. And again, of course, this is all looking back to historical data, assuming that the near future will be something like the recent past. So then here's the constraint that we would like to enforce. So this is the mean return. So if I allocate things this way, this is what my average return is going to be. That's what the return of this portfolio is expected to be. But now I'm saying, here's going to be a cell that I would set the value of. So I'm saying, no. I need at least 0.035%. So I would like somebody, not me, but somebody, to come in here and play with these numbers, subject to a few constraints. Increase, give me a little more Apple here. Give me a little more Microsoft. Give me a little less Oracle. Make sure that equals 1 here, because this is the sum of these weights. It's just the sum of this vector of numbers. That's got to equal 1. Got to have 100% there. And once we've done that, let's find out. We should be able to improve this. Let's go ahead and try to get us up to 0.35 on this. If I was trying to increase my return, what should I do here? Well, probably should increase one of these stocks that's a little bit higher. Let me first take my standard deviation and remember it. So I just copied the value there for the standard deviation. I'll give myself a little more Microsoft. I'll give myself 0.2 Microsoft. And I'll give myself, let's see, what are my lower performers here? Oh, everyone's kind of about the same. American Express, I'll do 0.05. And ExxonMobil, I'll do 0.05. Did that do it for me? No, I'm down here. Still not to 0.35, 0.32. So I'll give myself 0.3 of Microsoft and reduce Ford to 0. Oh, I'm so close. ExxonMobil down to 0. Microsoft up to 0.35. Okay, I did it. So here now, I've increased the expected return from this portfolio. Right, I now have 0.36, or 3.6%, and I'm only requiring 3.5%, so that's good. But what's happened to my risk to be able to do that? My risk has gone up. Well, we'd expect that. There might be ways, maybe I just had an arbitrary distribution at first. I might be able to get the expected return to go up and the risk to go down at the same time, but I wouldn't expect it. And so here's what I'd like to do. I just went through that process and changed a few of them. And I'm saying, well, how can I change that now so I'm still above 3.5% here, but make this number be as small as it possibly can be. Right, so achieve my expected return and reduce the risk as much as possible. That's what we'd like to do. There's no analytical solution to this. I can't just There's no algebraic formula where I could just solve this function and get my, see the result. And so what I have to do is have someone that can do that guess and check procedure that we just went through, but have them do it thousands upon thousands of times a second. And that's exactly what the solver is. How many of you are thinking, you know what, I'm already pretty comfortable with solving? It's like maybe 10% of the class. Okay, so what we're going to do is we are going to set up solver once by hand, and then run it, and then we're going to record ourselves setting up a solver, and then we're going to go take a look and understand the code. So, solver is on my data tab. Way over here at the right, I will see the solver up here. So I'll click on solver, it'll bring up a dialog box. We'll say, all right, we're ready to start solving. So here's the thing with solver, we get one objective. So there's one cell that we get to try to say, make this cell as the number in this cell as big as possible, or make this number in this cell as small as possible, or make it as close to a particular number as you possibly can. That's it. We're limited. We got one cell that we can optimize on. So based on how I've described this problem, what's that cell going to be? Yeah, it's D4. It's D14. It's my standard deviation of my whole portfolio. And so, well, that's the cell I was on, so that came up as D14. If not, just go click on it. I don't want to maximize the risk. I'd like to minimize the risk. Okay, so that's my target. I'm going to try to minimize D14. Now, by changing which cells? By changing all of these weights. All right, solver, as you fiddle with this, you're allowed to change all of these. Now, I'm subject to a few constraints. Look, if we wanted to make that number as small as possible, what could solver do? Put a bunch of really, really small numbers in this. You know what? Negative 10,000 in each one of these. And that, well, see, I'm not sure what would happen with it. Anyway, if we get down to 0, that's going to give us pretty small. Actually, it's not just getting it small. What else would give me a really small standard deviation? I guess 0 is the only one because it brings in, it's not just these numbers, it's looking at the means involved with these numbers too. So, yeah, but of course, I want to say, listen, I've got to allocate 100% of my portfolio, so the sum of the weights has to be 1. Whatever you do, if you increase something, you've got to decrease something else. And so that's right here. That's what this formula is here, sum of weights. It's already 1, but I've got to make sure that that equals 1. And so that's going to be a constraint. So I'll click on add, and the constraint I'm going to say is that this has to be exactly equal to 1. I can click on OK, and that'll take me back to the other dialog box, or I can say, you know what, I've got another constraint to add, so I'll click on add. This is even set up to kind of help us on this, is that it says, here's the constraint on the mean return. So this is the expected mean from this portfolio. And I need that to be greater than or equal to my required return, which is right here in F10. Now, you'll notice that this put a formula in here when I clicked on it instead of just typing it in. That's going to become important to us here in just a minute, but we'll just notice that at this point. So we'll say OK. Now, this comes up checked by default, make unconstrained variables non-negative. That means you're not allowed to make these variables go negative. Okay. We could relax that constraint, but we're allocating this. We're not selling short, so we can't have a negative amount of stock. And then there are options that we could set here. That would be how many times is it allowed to iterate, and what's the precision of these numbers it's going to move in. We'll accept the defaults for those. And then we could choose a different engine for doing the solving. I'm going to stick with the nonlinear one here, primarily because I don't know the difference between those engines. We'll just accept the default. Then we'll go ahead and click solve. It says solver found a solution. All constraints and optimality are satisfied. So, I'm going to go ahead and say keep solution, and we'll take a look at it. So this is actually pretty interesting. My constraint on return that we started off with was halfway between these numbers. I just remember that because I wrote the worksheet that does it. So it was 0.27. And when I was allocated at 0.027, this was my risk in this portfolio. I was equally allocated out there, and my required return was 0.27. I was at 0.053. Now I've come all the way up to 0.035, from 27 to 35, And I've been able to even do that while reducing my portfolio risk. So this is a much better portfolio than I had, just equally weighted. It's getting a higher expected return, and it has less risk. This is great. It's exactly what we want this thing to do. So you'll see my prediction about having these guys both performing pretty well and being opposite each other. At least it doesn't bring Apple in at this particular required return. That's why I'm a coder, not a finance guy. So it says, don't buy Apple, don't buy Ford. So what do you think? Late 90s, don't buy Apple. Good advice or bad advice? That's extraordinarily bad advice. How was Apple doing in the late 1990s? What happened in the early 2000s? It's 4 letters. What was it? iPod. Apple parlayed the iPod and become the most valuable company in the world. It's amazing. All right, Oracle, Southwest Airlines, Costco, all these, don't buy, at least at this particular location. This particular required return. Questions here? Yeah.
It just seems like this is somewhat similar to the traveling salesman problem, and yet it does it so quick, and yet traveling salesman problem is like impossible.
So guess and check. Okay, so let's
what
think
are
about
the main differences? Because
That's
I feel
a good
like
question.
it's just guess and check.
Yeah. Let's go ahead and let me restate that question for the recording. So the question is, hey, this seems kind of similar to the traveling salesman problem. Traveling salesman problem, so a lot of calculations to do. Doesn't seem that much bigger than this one. I mean, here we got 10 stocks, but the fact is, if we had 36 stocks, so we had 36 cities, we could still solve this very quickly here. So what's the difference? I mean, we demonstrated traveling salesman problem doesn't have an analytical solution, not one that we can solve, that we can compute. Anyway, I mean, it has one, it's just not computable with current technology. So the fundamental difference here is that in traveling salesman, what we had to do is we said, you know what, just guess a route, and then calculate how that route does. Guess another. It's not guess and see did we get closer. It is you've got to calculate them all. You'll see which one's smallest. We don't have to calculate every possibility here because what we're making an assumption here that says, if we move this one a little bit in this direction, it's probably going to have a similar effect if we move it a little bit more. So if we push this number up a little bit, we can look at our target. That took us the wrong way. Okay, don't do that then. Push this one down a little bit. And so we don't have to try all possible combinations. We get clues as to the direction we should move by looking at how the function behaves. That's the fundamental difference. And that's what Solver does. Solver says, well, just try something in these inputs and then record what that looks like, change something and see did that make it better or worse. Oh, made it better. We'll change a little bit more. And depending on the underlying dynamics, we'll push that up a little bit, and if pushed too far, it might bring things down. So we've got to find the right level for all these different things. And the truth is that you're not guaranteed to get the same solution every time. There could be multiple solutions that would get me to within the margin of error that I specified here, and that would be okay. Okay, other questions? Okay, so next step is to record ourselves doing that so that we can take a look at the code. Now, folks, a little warning here. How many of you have ever looked at the code that was written by the macro recorder and you went, oh my heavens, why did they write it that way? Almost every time I look at it, I think that. Now, here's the good news. Kind of the good news about that is that the folks so far, all the code we've seen has been written by Microsoft, by folks at Microsoft. They're drinking the same water up there in Redmond, Washington. They all have the same kind of weirdness. It's kind of a uniform weirdness. The code that we're about to record is going to be written, the recording mechanisms for that are written by the guys at Frontline Systems. Totally different. And it's going to be even weirder. So hang in there. Let's go ahead and do it. So I'm going to turn on my recorder. I'll give it a name, Macro1. That's a fabulous name. I'll leave it Macro1. Say OK. All right. So now back to my solver. So go to my Data tab, Solver. Oh, my heavens, the thing's already filled out. It's okay, because the first thing we want to record ourselves doing is blowing the model away. And fortunately, there's a reset all right here. So I'll just come to reset all, and that's my first thing to do, reset all, and it just resets the model. Everything's set back to normal. Now we'll just go through that process again. Set my objective. I'm going to come to my portfolio standard deviation, make sure I minimize that. By changing cells, going to be my weights. I'll add those same two constraints. So Sum of weights has to be exactly equal to 1. Add another one. My expected return has to be greater than or equal to my required return. Say OK. And these are defaults. We left the way they were. That should be OK. And we'll say solve. Found a solution. We'll keep that solution. Click on stop. And we now record it. Now, I went a little quicker that time, but are we good? Anyone let me catch up before looking at the code? All right, let's take a look at the code. Alt F11, look at module 2. Okay. So far, not too bad. Figure out what this is. First thing we did, reset the solver. Here it is, solver reset. If only they were all that clear, we'd be in good shape. Let's look at the next one. The statement, this is just a statement that's built into the library that comes along with solver. This is a statement that says, solver OK. Seems like a weird thing to say, but here it is, solver OK. This doesn't look too bad. Set cell equals D14. So that's the cell we're going to try to maximize, minimize, or get to a particular value. And the next argument here, max min value equals 2. What does 2 mean? Minimum. How do we know that? Well, we chose minimum to record it. And maximum's probably 1. Well, I don't know. We have to record those, see what they are. Value of probably gets ignored unless this is set to value over here. Now, here's the first problem. We look at this code here. By changing B4 to K4. What's the problem with that? What's that? It does know it's a range, and this is okay. This will actually execute. This is fine. But think about the model. How does this model work? How does this whole program work? What's the first step in this process? I got to pick the number of tickers that I want. So I can have 5, I can have 20, I can have 25, whatever many I want. And so if this is saying only change to this location, anything that goes wider than this is going to be a problem. And so I'm going to have to make this dynamic. So that's going to be the first thing I'm going to do. This doesn't need to be fixed, so I'm going to take these dollar signs out just to make it look a little bit easier to work with. B4 to K4. I don't want to end at K4. What do I want to end? Yeah, the end of that, whatever it is. Now, we're going to see that this has to be the active worksheet. So I'm just going to end that there. I'll just work with the active worksheet. So I'm going to say cells. Which row do I want? 4. Which column do I want? Columns.count. That'll be the farmost right column. From there, what do I want to do? And XL to left. And that will take me to the cell that I bumped into, right? Start all the way at the end of the worksheet, come back in until I bump into some data. And what do I want from there? I want the address. I want K4, because I've got to get this to be the string B4 column K4. In fact, I know enough about this. It's going to return the dollar sign, so I'll go ahead and put these dollar signs back in here. I don't think it would matter one way or the other. At least this way it'll all be fixed B4 to K4. You see what we did here? It's recording a fixed range. We got to say, no, that's got to be dynamic. Let's go figure that out and bring it in. Next arguments are which engine it's going to use. It's funny because you have the engine and the description both, but presumably they're a package deal. It's a nonlinear engine and it's number 1. So we've told that to bring that in as a dynamic reference. Questions?
I didn't understand the columns count. And
okay. Here, let's do this.
I understand that they're getting the address coming from.
I'll talk us through it. Let's take a look at this line. So first of all, let me come up here and say I want to just print that address. That comes out as K4. That's what I'm after.
Yeah.
Now the question is, how do we get there? Okay, so let me do this. Let me get rid of columns count here and say I'm going to start at 4, column number 1000. So that's column 4, way over, or I'm sorry, it's row number 4, way over here, column 4000. From there, I want to come back until I bump into some data. And that's going to give me the same answer. That's going to give me the same answer. So here's proof. Runtime, find cells 4. What does it not like about this? Oh, I wonder if I have that many columns. It seems like, I'm in compatibility mode because I renamed it. I opened up as an XLSX. How many columns are, sorry, I opened it up as an XLS file. How many columns in XLS? It's only 255 or 256 columns. So when I try to go to column 1000, it doesn't like it. But column 100 is okay. But then what I'm asking it, I'm saying, no. Don't just go to 100. Instead, go as far as you possibly can. And so columns.count just says, I want to go all the way to the end. And then from there, come back. If I was comfortable that I was going to have at least one stock ticker here, I could start here and move to the right. But I kind of like saying, you know what, let's just go until we go all the way out there and then come back. It doesn't take very long to do it. We solve really quick. Okay, so that's calculating that address. Okay, next one's not too bad either. Solver adds, we're adding a constraint. We're saying G7 has to be equal to 1. Okay? D10 has to be greater than or equal to whatever my required return is. This is just, it's a named cell, so when it brought this in, it used the name of the cell. All right, now this one's a little bit weird. We have another solver OK. What's it doing? Let's compare this to our old solver OK. Set cell D14, max value 2, value 0, by change, D14, engine. It's exactly the same as our other line was. What's the deal? What gives here? You think we need to have this one here? Well, if I was just trying it for the first time, I'd probably leave it there. Who knows what's going on? Turns out we don't need it. We'll delete that. Why does it record it? No good reason. Let's look at the next one. Solver OK. Set cell D14, minimize. By change, it's exactly the same. Don't need that one either. And then solver solve. So we're able to get rid of a couple of ugly lines, and it's not nearly as bad as it used to be. But it doesn't work. Let's go give it a shot. We come back to the code, and let me just give myself an allocation that's a little bit zero. I'm going to load everything up in American Express. Okay. So now, my risk is terrible, my return is terrible. Anyone should be able to beat this particular distribution. I'm ready to solve. So I'm going to come back and run my code again. This macro1 code. Run. Solver found a solution. Looks pretty good. But what's the problem? Do you see a problem here? Looks like this is met okay. My standard deviation doesn't look too bad. I like it. What's wrong? I'm overweight. Thanks for pointing that out. So, for some reason, this constraint didn't get respected. And here's the problem. You see how this says formula text? We can't just put a constant in here. It's got to be a formula. All I have to do is change it to be a formula. How do I make a formula in Excel? Yeah, put an equal sign in front of it. Equals 1 to do the trick. Now, the reason the required return works okay, I'm not exactly sure. What else if I put equals required return in there? Probably work okay. Yeah, get the right required return. So this is really expecting to be a formula, and for some reason, when it's a constant number, you've got to put the equal sign in. Put a note on this one because that's bizarre. Must add the equal sign to make this argument a formula. All right. So tell me about usability. What do you think? Especially if I'm going to solve, which we will do. I'm not just going to solve this model once. We're going to solve it, modify it, solve it, modify it, solve it, modify it, solve it, modify it. What do you think is a little bit undesirable about this. It's this right here. I don't want my user to have to come in here and say, oh yeah, go ahead and say okay, yeah, keep it. Fortunately, on the solver solve statement, there's an argument that I can put here. I'll hit space here. There's user finish. User finish. I think what this does is if I've got a user who's from Finland, it will put the results in his native language. Finish. Well, it does. It actually controls what happens with that dialog box on the end. Okay, so the name of it is user finish, and it's Boolean. It's either true or false. What should we put? User finish true or user finish false?
False.
Put it in, false. We'll run it. Nothing's still there. I didn't even change anything. User finish true. Runs just fine and doesn't put that dialog box up anymore. So run it. Anyway, so it seems backwards, but at least it works. A little fiddling, we can get that figured out. So now we're in pretty good shape. Here's what I want to do. I want to now integrate this into my existing code. So let's go take a peek at the code in Module 1 and see what we've got to work with. So we've got a thing here to show that ticker form, not a big deal. So here's build model. Build model says, hey, clear out the old sheets, build some new sheets, get some data, summarize it. Then it says configure the solver and run the solver. Those were commented out before, so we didn't run those. Didn't really have to comment them out because the procedures are actually empty down here. So here's run solver and config solver. Let's go ahead and figure out what do we have to put in for config solver. So back to module 2. How much of this do we need to configure the solver? What do you think? Reset, we need what else? Yeah, add the constraints. I think this is the part that's getting to configure solve. So I'm going to copy this, and I'm going to put it back there in config solver. And then I'm going to pick up that last line, solver solve true, and I'm going to put that in run solve. Now, I am telling it to change cells B4 to K4. Which worksheet is that going to work on? Which worksheet is that going to figure I should be changing? That's the active sheet. Well, what could I do if I wanted to change a model on something besides the active sheet? It seems like a reasonable thing to say, you know what, let's just tell this which cell on which sheet we want. On which sheet we want, everywhere that is referring to a cell, refer to the sheet that we're talking about, we should be okay. No. It turns out that the solver is written to work on the active sheet. There's no way to say, I want to solve a model that's on a different sheet than the active sheet. The sheet's got to be the active sheet. If it's not the active sheet, here's what happens. You run the solver, and it says, listen, I'm trying to figure out a model here. It's going to look at B4 on whatever sheet is your active sheet. It's going to do all of this, assuming that your active sheet's the one it should be working on, and it's not going to optimize the sheet you're after. So you must make the sheet you want the active sheet. So I'm in front of both of these. Anytime I'm referring to the solver, I'm just going to say, let's just make sure that sheet is active. So I've got a sheet. The sheet is named model, and we're going to activate it. Move. Model. And I'll do that for both configuring the solver and for running the solver. See, I don't know what's going on, what was happening just before this got run, but I want to make sure that before I hit solver solve true, I've got the active sheet, the right active sheet, and I've got this one to be the right active sheet. So now I should be in pretty good shape. In fact, I'm going to go ahead and run this whole thing again. Come back to tickers. Maybe I'll change. I don't want to look in the late 90s. I'm going to look recently. Why don't we go to /1. Actually, let's go to, what's today? 17th, /17, 2017. And back to 1/1, 2012. Let's look for a little bit more than 5 years of data. And I'll process this model. Again, it should blow away all those old sheets, recreate them, import the data, build the model, and now it should optimize that model too. And so here it is. It's coming and giving me a very different idea. You know what? You should buy Apple. In fact, not saying to buy a whole lot of Apple. Well, yeah, it is. It's saying that you should put 0.3 if you want. Yeah, it's saying buy as much Apple as anybody. It's like Apple, more Apple than anything else is what it's saying. No? Oh, it's 10 times as much as Costco. Yeah, go buy Costco is what it's saying. But it does want you to buy some Apple now. Southwest Airlines wants you to buy IBM, Ford, forget it. Okay. So at this point, we're feeling pretty good. And in fact, the optimize button should be working now too. So I can say, you know what, I want 0.02 out of this. I should be able to hit optimize, and it'll now just run that. So this is just a call, creates a button that's got a call to that particular sheet, or that particular, what's it called? Run the solver sheet. Questions? Back to the code. Run solver and config solver. A couple of keys here. What we have done is we have uncommented these two, run solver and config solver, so when we run build model, it runs these, and we've built these out. Be sure to activate the sheet with the solver on it. Activate. Okay, now here's the next thing I'd like to do. So what this does is this arbitrarily picked halfway between my minimum return and my maximum return and just said, let's suppose that's the return we're after. What we'd like to be able to do is we'd like to be able to say, hey, give me a feeling for what I can do with this stock. You know, start at the minimum return and then give me a chart that kind of shows me in steps between the minimum return and the maximum return. That's what I'd like to see. That's called the efficient frontier. It shows me, given a specific required return, how much risk do I have to absorb? You'd expect that the more required return I need, the more risk I'm going to have to take. But here's the thing. For any given required return, whatever number this produces for risk, I should be able to take on more risk if I wanted to for some reason, but not be able to pick up less risk. So this chart should give me a kind of an area that says this is all the place you can be. You know, the only place you want to be is somewhere on the line, but that's called an efficient frontier, and it's pretty easy to generate. In fact, all we would have to do is say, I want to record my expected expected return, required return, and my portfolio standard deviation, and then just chart it with an XY chart. And that's exactly what the next procedure already does for us. So let's take a look. I'm going to uncomment find frontier. Find frontier is fully written for us already. The find frontier just says, listen, how many steps do you want? What's your number of increments that you want? Number of increments? Anyway, I'm asking for steps of 10. Take the distance between my minimum expected return and my maximum expected return, cut it up into 10 pieces, and then use that to build my plot. I can push this to 20 and it would just do it a little more precisely. I'm then going to keep track of the minimum return and the maximum return, and then I'm going to reprocess the model from 0 to however many times we specify. And here's what we do. What we're doing is we're setting up the required return. This is what I do to re-optimize this model. Give it a new required return and tell it to optimize. So here's my new required return. Let's think about it when x is 0. It's going to be the minimum return plus 0 times something. What's that going to be? The minimum return. It's going to start off by giving me a measurement at the minimum return. Then when x is 1, it's going to come back and say take the minimum return plus 1 times the difference between my minimum and my maximum return. So how much do I have room to move between minimum and maximum? And then cut that up into 10 different chunks. And now add 1 of those to my minimum. Make a measurement. Add 2 of those chunks to my measurement. Add 3 of them. And we'll finally end up adding 10 of those increments to the model. We run the solver. We copy from the portfolio variance and the required return onto our frontier sheet. And then we copy the, just for interest's sake, to look at the weights. We don't need this to be able to build the chart. We copy over the weights that gave us those numbers. Once we're done with the loop, we delete any chart that might be there already. We add a chart, and we configure. So now I should be able to say run find frontier, and that should generate for me that chart. So here it is. It says, here's for these different levels of required return, here's the standard deviation that we're able to get. You'll notice that's increasing. And then here's the efficient frontier. As I increase my required return, I've got to take on more risk. I can be anywhere to the right of this, but I can't get to the left of that one. Questions? So, I mean, at this point, now that we have uncommented, have I? Yeah, I've uncommented the find frontier. I can go back, pick another range on my tickers. Say I want to, things will probably look different from, say, 2008 to 2012. So let's take this down to 2000, what don't we say, 2013. Process that model, and I should end up with a different look. Of course, not remembering what it used to look like will be tough to know. The shape actually looks quite a bit different. I'm kind of surprised by that. But now it says, don't ever buy American Express. So it says sometimes when you want to buy, I said you almost always want to buy IBM. So it matters where you're looking initially to know what to buy. But you can now say, pick your stock ticker, pick your date range, and it'll give us, kind of give you the whole picture about what you might be able to do with that portfolio. Questions? You can see how you could take the same thing and you could say, you know what? Well, I just like to choose lots of different possible portfolios. Run it and see what happens. Run it and see what happens. Run it and see what happens. Let it run for a week. I don't know. An algorithm that figures out how to plug these in, and who knows? You might find something interesting. Oh, I did that much quicker than I did in the last period. That's exactly what I wanted to cover today. What questions do you have? Yes, go ahead.
So solver has constraints about the number of variables it can solve for, or variables can interact.
So the question is, solver has how many of these can we put in? Could we put in 1,000? Would solver do it with 1,000? I don't know the answer to that. Presumably there are, and that strikes me as the kind of limitation that would be the first on their list to say, you know, if someone wants to solve huge problems, get them to pay us a little more money than the one that comes for free. Is your question, what are the limitations?
Right, how to get around it. So I've tried using this for like a 360-month mortgage. I'll go through it, and I don't remember what the limit is, but I want to do 360.
Changing 360 different things is too much.
So like, I guess trying to find a way around it, or how to use it. How to iterate through solver.
Well, there's a very easy way to get around it. I'll tell you in just a second. Solver, model size limit. Standard Excel solver dealing with problem size limits solver. So you can tell us what the limit is? It's like 200. So the limit on constraints depends on the type of model, linear or nonlinear. It's easy to upgrade. Yeah, there's the solution. Upgrade to the premium solver products. You see what they cost? Well, this is coming from Frontline Solutions. No wonder they said upgrade. 15-day free trial. That's the one you want. Quick, solve. I'm just not seeing the price here. They might not want to show you the price for fear of sticker shock. But yeah, I'm not really an optimization guy. I'm a coding guy, and so yeah, I've probably now said almost everything I know about solver, and some of it twice. So I don't know any tricks to get around this particular limitation. But yeah, you're right. It's like 200 is the limit. Other questions? All right, let's call that good for solver. Stop recording.